So we're doing examples of raising powers to powers using the exponent rule power to power. That's where you're going to see an exponent out here on the outside and some exponents out here on the inside. So the rule goes, you're going to end up multiplying those exponents. So ultimately, both of these are going to end up getting multiplied by this 5. The 6 is going to work a little bit differently with that 5. Coefficients get raised to that outside power. So basically, they're going to use that exponent like normal. And that's actually where we're going to start with this problem. So if I start with the 6 to the 5th power part, remember that that is not 6 times 5. It does not equal 30. 6 to the 5th power means repeated multiplication. So 6 is going to get multiplied by itself 1, 2, 3, 4, 5 times. And if you do that, you should get 7,776. So that will end up being the coefficient on our final answer. For my exponents, this is where we're going to end up doing 3 times 5 to get 15. And that's going to just happen twice for both of those exponents. Oops. Okay, so to build my final answer, I'm going to have 7,776. Again, that's coming from 6 to the 5th power. If you cover it up, it makes it look a little bit more like we would expect. Then I have x to the 15th power after doing 5 times 3, and also y to the 15th power after doing 5 times 3 one more time. That makes this my final answer. Okay, so that problem was completed using the actual exponent rule, but there are other ways to think about this rule as well. If you prefer the multiplication rule, which a lot of people find a little bit easier, you can also do these problems using that rule as well. So I'm going to do this next example both ways, first using that multiplication rule and then comparing it back to what we just did in the last example. So the multiplication rule relies on your knowledge. The exponents mean repeated multiplication. So what this problem is actually telling us is that this inside part happens 2 times. So I'm going to write it that way. So I'm going to say 3x to the 3rd, y to the 4th times the same thing, negative 3x to the 3rd, y to the 4th. So if you think back to the multiplication rule, if you don't remember the multiplication rule, I also have a video showing examples of the multiplication rule on my channel. So what I can do is I can multiply those coefficients and I can add my exponents instead. So negative 3 times negative 3 should give you positive 9. 3 plus 3 makes 6, and 4 plus 4 will make 8. And that makes your final answer using the multiplication rule. Now, if we start using the power to power rule, like this set of problems would ultimately want you to try out, we can get the same answer. I would think of this as negative 3 squared, which again would be negative 3 times negative 3 to get positive 9. Should sound familiar from over here. And then as I do my multiplication, 2 times 3 will make 6, and 4 times 2 will make 8 as part of my exponents. So if I go to build my final answer, negative 3 times negative 3 is positive 9. I'll have x to the 6th from 2 times 3, and y to the 8th from 2 times 4. So then you can see that you get the same answer no matter which method you use. Only one other strange thing that might come up is remember, if you see terms or chunks of your problem that have no exponent on them, those exponents are 1. So it's just important to know for when you're multiplying that outside power by the inside things, just don't leave that guy out. So I can use my rule. 3 squared, again, is 3 times 3, which will make 9. 1 times 2 from right here is going to make 2. And 3 times 2 will make 6 for my exponents. So again, 3 squared will make 9. 2 times 1 will make 2. 2 times 3 will make 6. The multiplication rule could also apply here if you prefer.